Okay, so we did disc yesterday. We're doing washer today. So the volume of a washer is pi times capital R squared minus R squared times W, which would be the width. And if you look at our picture, capital R is from the top to your axis of revolution, and little r is from the bottom to the axis of the revolution. Okay? Because this is a washer, there is a what in the middle? A hole. So this right here would be the hole. And if you think about it, it's just like when you had your curves, the area between two curves. That's what's going on. So the volume equals pi, the integral from a to b of r of x squared minus little r of x squared dx. That's it. So this picture right here, this little, I don't know, what do you want to call it? What shape does that look like?
A hole.
Which one are you?
The blue one, the one with the green arrow.
Like a cone?
Like a crescent.
Like a funnel that got part of it.
To me, it's like a crescent moon, like a little part of a
It
moon.
looks like a contact lens.
Okay. But if we rotated it, guess what it would look like?
A
Not a
washer.
contact lens anymore.
It looks like a dog cone.
Looks like the bottom
Looks
of
like a
the
funnel that got the
shuttlecock.
bottom cut.
Mm-hmm. I like a dog cone. I think it really looks like a dog cone to me.
Yeah, that's definitely.
I would say you're probably the most accurate there.
I don't get crescent.
Okay, so I have a silly question.
What? I like the contact lens.
On the volume of the washer and then
Oh,
like,
that? I thought you were talking about the other one.
No.
Well, you have arrows over there, and you were talking about.
I
that one, too.
drew this arrow right here. Anyway, what was your question?
There's arrows over
Okay, so you have the two different
Which
little
one?
formulas they give you, but we're supposed to use the one in blue.
Yes, because the top is just the volume of a regular washer. Just of like a washer. Use the blue one.
And then I had to draw the little R thing so I can remember.
There's a lot of brackets and parentheses in that definition, isn't there?
Yeah, I mean, you know, right?
I don't know if I'd have the square brackets there.
Parentheses in brackets in parentheses.
I might just write. I don't know, but you almost have to have that. Because you can't put a squared there, because that's weird. I don't know. It seems like there's a lot. Okay, we ready?
No. Just too busy trying to figure out
Who's this stuff up?
which washer you were talking about. I still don't know.
The yellow goes with the yellow, and the blue goes with the blue. The yellow goes with the yellow,
What yellow?
Oh, like the.
and the
picture.
blue goes with the blue.
Somehow you're trying to help make that more complicated.
Okay, anyway. Okay, so this looks like a flower petal to me when you start. It look like a flower petal?
I think it looks like.
And then it looks like some kind of a bowl once you rotate it.
A Mexican bowl.
A Mexican bowl.
The design on this side from the pedal.
Oh, from the petal. Okay, I was like,
Like a Mexican chip bowl.
okay. So, find the volume of the solid formed by revolving the region bounded by the graph of y equals the square root of x and y equals x squared
Is this even a washer?
about the axis. Yes, because of the fact is that you would have a hole in the middle. Like,
How would you?
all this area in here is empty.
Oh.
Because this area all in here,
Okay.
It's empty.
there's empty.
So it doesn't have to be like a hole
doesn't have
that
to be a
goes.
hole.
It doesn't have to be a giant hole, no. But where you did the disc method, it was all laying
It was like-
on the axis. There was no spaces.
Oh.
Does
So
that make
like-
sense?
So it doesn't have to be like on both ends.
No, it doesn't have to be a hole all the way through. Because both of these go to 0, 0, so that would collapse it down. Okay, so we need to write this thing. Well, what's capital R first?
It's the whole space from the edge of it down to the axis.
Okay, so what's the top? Which one's the top?
A one.
Like which equation? Is it square root of x or x squared?
Square root of x.
Square root of x, because it's the top function, right? And little r of x is x squared. So volume equals pi, the integral from what to what?
Integral from 0 to 1.
0 to 1 of,
Are you, so, okay, stupid question, the 0 to 1.
Yeah, it is.
You take the numbers of whichever axis it's turning on.
yes.
So that was off the x.
So we're on the x, yes. If I was doing the y, it also would be 0 to 1, but this wouldn't be r of x, it'd be r of y.
Y.
And actually, if it was y, then the x squared would be the capital R.
Oh, because it would be opposite.
Mm-hmm. Because it would be rotating this way.
So then the one on top.
So this on top would be the furthest one away from the axis.
Correct.
Okay. That.
So you do have to be cognizant of which axis you're revolving around. Okay, so it's capital R squared, right? So square root of x squared minus little r squared. So x squared squared dx. So we can rewrite this to a much easy integration. Yes? So the square root of x squared would just be x minus
X to the 4.
x to the fourth.
Should just be negative x to the third.
No.
But you can't do that. Because this is integration.
You can't do that anytime.
Yes, you can.
No, you cannot.
Sure you can.
Oh, I got to think of a math one for you. Okay. So, integral's gone, right?
Yeah.
So 1/2 x squared minus 1/5 x to the fifth from 0 to 1.
Yep.
So 1/2 minus 1/5 minus 0. So 5 minus 2 is 3/10. So 3 pi over 10.
Yes.
And I really hate that they don't have units. It's really bugging me.
Not the units.
I guess we could go units cubed, which is really weird because we're used to using u's and things. Do we want to do one on the y-axis?
Well, if it's the same.
It's pretty much the same.
It won't change.
No,
very much.
it's just when you do it on, like I could do the same one and rotate it about the y-axis, but then like I said, it's the capital R is furthest away. So this would be my capital R, and this would be,
But the equation's still the same.
R.
You still plug it in.
yeah, the equation is exactly the same, but instead of dx, it's dy. Everything's exactly the same.
Okay.
We good?
Yeah.